on our meeting. طيب، بسم الله الرحمن الرحيم، والصلاة والسلام على أشرف الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. Assalamu alaikum everyone. Thank you very much for joining us here. We welcome and we are glad to have a very distinguished guest with us, Mr. and Engineer Naeem Altaf from IBM. If I can give a little introduction to our guest. Brother Naeem is one of the people that's really hard to introduce. Has very big profile of activities and achievements. He's now an IBM Distinguished Engineer and IBM Space CTO. He had his bachelor degree in computer science from the University of Texas at Austin. He is a member of the board of advisor at Explore Mars Incorporated. He's been working for IBM for over 20 years and got many ranks and titles, one of which is the IBM Distinguished Engineer, Chief Solution Architect, and Cloud Solutions. Brother Naeem is working for the space tech industry. These a group of various companies. That's just a short introduction, and I'll let Brother Naeem take the mic from here. حياك الله brother.
Assalamu alaikum everyone, and thank you so much for the introduction. So let me share my screen and then inshallah we'll start. So let's share the screen here. If you can please enable my sharing.
Sure.
Okay, I can share now. So if I go can everyone see the slide deck?
Yes, it's clear.
Okay, cool. Okay, so yes, no, thanks for the intro. So let's start. I mean, today's topic is around new space age. As you probably all are well aware, there's a lot of activities happening. Almost, we hear so much happening in the space world almost every week. So we thought let's give some overview. So this is how we started. So back in 2020, just before the COVID, when we had Jim Whitehurst, our president of IBM, he came from Red Hat. He was a CEO at Red Hat. So we presented to him the opportunity for the emerging technologies and markets, and he was the one who appointed me as a CTO for space. And from there, we started this journey. So my background is computer science and not aerospace, but I've been working with NASA and Frontier Development Lab here in California for past 5-6 years, and that's where I learned that it's a software-defined world, right? So if you don't have to be an aerospace engineer, because there are so many elements of compute and running different kinds of programs. If you are if you are into computer science, there is a huge area, and just like mentioned about the spatial temporal analysis, that's another. As a programmer, there's a huge area with the satellite imagery, and there are so many different techniques of images we're getting, and we'll talk about that soon. So that's how I have always operated in IBM. It's been almost it will be 23 years in August. So you have always go for your passion. Of course, you have your day job which you do, but then you're always looking for some innovative areas besides your day job. And as a DE in IBM and any other industry, it is expected for you to be working on multiple fronts and exploring different areas to see where we can innovate and grow. Okay, so just a quick small history. I mean, IBM is no stranger to space. If you know about space, the Apollo missions going back to the moon, IBM played an integral part, and there were like almost 4,000 IBMers dedicated to work on that. But it was a national program, I guess, at that time. And so, they did from mainframes and putting men on the moon. Just that quote, which from the flight vector, which says without IBM, systems they provided, we couldn't have landed on the moon. That's a huge compliment for the company. After that, we were still involved in many different areas from, the Mercury and then other the missions, and then the space shuttle era for almost more than 2 decades we were involved in. So we've been in this, we work with NASA, ESA, with the Japanese Space Agency, we work with all the major agencies. But now, as you have seen, it's just kind of exploding, right? There's almost every nation is aspiring to have their space agency up there, and so we talk about that. So what's our vision? Why we started this space space tech area? We first of all, we as IBMers, the core is we believe in innovation. We are always we do so many amazing things. You probably heard about this Mayflower ship, autonomous ship, which the ship which sailed from UK to Boston area, fully autonomous. That we just finished that. It sailed last year. We started that work 3 years ago. So I was one of the key architects on that, working on how we build the solutions, and that was an example of extreme edge computing. And now I'm working in the space. So our goal has always been, how can we innovate? How can we do some groundbreaking work and open up new areas where it benefits not only the company, but also the humanity, and how we can work on a much bigger, larger scale. Okay, so here's the question, which people will ask, right? Why space? There are, in today's world, we have many challenges. If you look around, right? There's challenges almost every other day you wake up, something is going on. Major challenges from political to climate change, and then the ocean cleanup. We have so much plastic or microplastic in the oceans, right? So how do you clean the oceans? How, with all these changing patterns in the climate? I mean, we just saw in your part of the world, I think a month or 2 months ago, the green grass, right, in the desert. And that was just amazing. Even though there are, from our point of view, from our beliefs, right, there's a hadith also that, and there's a lot of history behind that. But again, from the worldly point of view, you see all these changes happening. So why space? So we all are directly or indirectly connected with space. So think about let's start with your smartphones. The moment you wake up, or most people, right, they're checking their phone. They're looking at something. If they're leaving for work, they're looking at the traffic patterns or looking for the weather. How's the weather going to be today? I don't remember doing this 20 years ago when I was in school. We didn't used to go and check weather every hour to see how the weather is going to do all these things. But now with these technologies, and these are all the satellites which are in the orbits, they are providing you all these amazing kind of information. So it has become an integral part of our daily life, spaces. And there are many use cases, and it's actually improving, especially the people who are commuting for long distances. It's a huge help. There are many use cases. Let's start with Earth observation. That is the largest use case for from the space point of view. Besides, of course, the defense and all that stuff. But Earth observation, where you're watching the health of your planet, or you're looking for weather forecast, or looking at the droughts, or the melting of glaciers, your crop health, all these things. We can with all these amazing satellite imagery, using different kinds of techniques, from optical to SAR, synthetic aperture radar techniques, right? I mean, I was just reading this week that there are companies like with using AI techniques, you can get up to 10 centimeter resolution, 10 centimeter. So we have seen resolution from the commercial providers up to 25 centimeter, companies like Maxar, Planet, right, 25, 35. But just imagine you're almost 400 to 500 kilometers above, and your resolution is 30 centimeter. And with all this phenomena of generative AI, we'll talk about that, you can further enhance those pixels, those images, and can go to 10 centimeter and probably beyond that. So that's one use case. Disaster response. So whenever we have a disaster, the first responders, they want to get the information quick, because time is of essence, right? So if there is a floods happening or fires, they want to know because with limited resources, which are the most affected areas and where they can go and quickly. So doing basically before and after of satellite imagery. And now with with this satellite connectivity, internet connectivity from satellite. And yes, please go ahead.
Sorry to cut you, Mr. Altaf. I just wanted to know, how do you want to steer this presentation? Should we ask questions when we have them or buffer them until the end?
No, let's ask. Let's have an interactive session.
Okay, good. All right. So
go ahead.
I just wanted to know the specifics of IBM involvement in the GPS technology. So I know that the GPS is handled by the US military, basically, and it's a very critical system. But one of the, for example, the current worries about GPS is how can we protect that? The war in space, the availability of the GPS systems are the most critical point and are the most important thing, as opposed to its own value, like the hardware and the system that's developed. So how IBM is involved in developing such systems that guarantees the fault tolerance? Because in my opinion, I think fault tolerance is the highest priority in such systems.
No, I totally agree. Yes, and GPS. I mean, if you just read about, I mean, GPS satellites is not only for giving you directions, but also if you think about all your real-time, stock market stuff, running the clocks on the ATM machine, the banking, it's hugely used in all those systems. So, but I mean, if I personally don't know who is directly working from IBM in which areas of GPS, because if it probably will be the Fed area in IBM. And that requires certain clearances and all that stuff. So personally, I'm not involved, but we can find out afterwards and see who is involved, and maybe you can connect you with them.
Gotcha. Thank you.
No problem. So so disaster response, like I mentioned, and now with the companies like Starlink and others who are trying to provide you this internet connectivity. So think about if you're in a remote area with because once a disaster comes, you lose your infrastructure, like your communication lines, all that stuff, electricity. So you need so you can go and put your dish there with a generator, get the internet connectivity, and start doing something with the data. Communications, of course, you have these the TV and everything. Global, we just talked about GPS, the ISS. So we have space station right now, ISS, the International Space Station. We have a Chinese space station which is being built at the moment. And then space station ISS will be out of commission. They are targeting end of this decade, by 2030. And then there are 3 new companies who got the contracts to put the space station up, like Sierra Space, Axiom, and others. And we are working with Sierra Space in some. So anyway, so then there is economic impact, and that is huge because I think it lifts the morale and the of the nation. If you're saying from this country, we are working as a nation on the space projects, right? It's very uplifting, and that's what's happening, across the globe. And one of the 2 agencies which comes in my mind, which I have noticed in the last 2-3 years, are going up very, very fast. One is the Emirates, UAE, and the second one is the Australian Space Agency. Of course, the China has been working on for a long time, but these 2 I have seen. Just if you look at UAE sending a satellite to Mars, right? So quickly that they've been not working here for last 70 years. Just recently, and look, they are able to put satellite in the Mars orbit. And so there's a lot of, and they have many other plans going forward. So and so is now other nations like like the Saudi, but their 2030 plan, and other countries. Everyone is trying to put something, be part of this space. So since it's an emerging area, there will be many rules and regulations which will automatically come into place once the space gets congested. Because before it was only in the hands of few, right? Up till now, few countries and few nations, but now with the privatization. Then the other use case is the security, where you're looking at the borders and all for the D&D, Department of Defense, how they use all this imagery from the satellite. And then last but not least is the innovation. There is so much innovation, right? We launched a Cubesat last year in May, and I'll tell you that story when you get that slide. There is a lot of innovation required. It's not as simple as I thought it will be, but okay. So let's go to the next slide. Let's look at a global economy, space economy. So if we look at from these major, financial companies like Goldman Sachs, Morgan Stanley, it's listed as $1 trillion industry in the next 15, 20 years. And the reason is because there is the cost. Just for example, the cost to deliver something in the orbit by space shuttle was around $65,000 per kg. Today, it's $1,500 per kg. So you can imagine how cheap. And soon when the Starship, which goes up the big rocket, which I don't think you can see. All right, here's the Starship, which you probably have seen. This is a 3D constructed. So this Starship, which is supposed to have its first maiden flight, I think, very soon, in the next couple of weeks. And actually, it's here in Texas, in Boca Chica. I drove there to see that. It's like 6 hours south of Austin. So once this thing goes up, you have seen how gigantic this rocket is, with 33, I think, Merlin engines. So the cost is going to rapidly come down. So these are the factors which have enabled the space, which have reignited space in the last 4 or 5 years. And a lot of work has been done by SpaceX, of course. Before, we used to have launched maybe 1 or 2 a year. Now we have launched almost every week because they're putting up their Starlink satellites to build this internet connectivity. So, and then there is the NASA, ESA opening up to the public-private partnerships, where they are work collaborating with all these companies. And we are seeing these human, because SpaceX took the private astronauts, it took the NASA astronauts to space station. Before, it used to be, other companies. And then there have been these other launchers like Blue Origin, who they don't actually go to all the way to the space. They only go to the Krammer line and come down. So anyways, then there are many other launchers. There are different classes of launchers, SpaceX, Rocket Lab. And then the other big thing which is happening is these mega constellations which are going up. So SpaceX, OneWeb, you probably have heard, they're putting these satellites to provide connectivity. And if you look at these numbers, right, 12,000, and the Chinese, I just saw yesterday that they are going to launch their first batch end of this year. So they want to have their own set of satellites to provide internet connectivity. You add up this number, you're almost looking at 40 to 50,000 satellites going up just in next few years. To date, we have only launched like close to, I think, 4 to 5,000 satellites in last 60 to 70 years. So yes, it's very cool to see this innovation, but it's going to also create lots of other challenges. We'll talk about that also. So, okay, just to give an overview of what is this industry, this whole space tech, what's the landscape here? Because as I mentioned, as a computer scientist, right, I always thought space, you have to be aerospace engineer or rocket scientist. But if you look at this landscape, there are many different areas. Yes, you need those special expertise who are actually building the hardware, the engines, the rockets, right? Different classes of rockets, or are building satellites or space stations. But then there's a lot of software involved here as well. So, and there's a lot of network connectivity, the 5G stuff, IoT sensors, how you connect IoT sensors to the satellites. Then this whole area of data analysis. So data and AI is a huge area which comes out of all this, stuff we are putting up in the space, because all the data which is being produced that needs to be analyzed, and you apply AI and you extract, meaningful information out of it. Then there is space tourism, then there is so many other things you hear about, that they want to build pizzas in space, or there's a lot of talk about manufacturing or chip manufacturing. So there's a lot of wild ideas happening right now. But you can see, if you are as a computer scientist, there is a lot of room for people to, be a part of this space tech industry. And then there's operations, right? So command and control center, where you operate, you're running your operations for all these satellites or whatever you're putting up in the space there. So,
pardon me, let me ask a quick question about this slide. Where is IBM? I don't see it here.
So we are in the software area, right? So we are as a systems integrator, right? So we don't build like a software for space, but we build platforms. And I'll give you the use cases coming. I'll explain. So we enable these technologies. So build platforms. For example, you will not see anywhere here Red Hat Linux but majority of the software runs on Linux operating system. So those things are enablers for these applications.
All right, I'll stay tuned. I'm sorry. Sometimes
No, it's okay. That was a good question. Okay, maybe when next time I build this landscape, I'll put IBM also there. Okay, cool. So let's talk about use cases. So 2 years ago, when we started this work, we wanted to do edge computing in space, because when you're in space, there are many different challenges. You don't have the luxury of running a data center like we have on our terrestrial networks on the ground. We can run in space because of for obvious reasons, the space, the electricity, how you're going to dissipate the heat, and you don't have enough bandwidth for network connectivity, the throughput, or the area to put your computer, all that stuff. So edge computing is a perfect scenario for these extreme use cases. So we engaged with the ISS National Labs and NASA, because NASA runs many different experiments on the space station. The space station is like a lab. It's in the orbit lab. So one of the key experiments they were running at that time was this DNA sequencing. So as you can imagine, when you run through a DNA sequence, so we take a sample, and the goal was to take a sample from the surface inside to see if nothing is growing over there, mold or anything inside the surface. So they'll take a sample, they run through this device, and it will generate 0.5 terabyte of data per run. Now, all that data has to be downlinked and then processed, and then go through all the hop. How do it's the people who work in the enterprise, they know how the data flows and how challenging it is to get data once it reaches the system and approvals, all that stuff. So, and by the time the data reaches in the hands of the PI, which is a principal investigator from NASA who actually asked for this, it's been weeks, several weeks. So we said, okay, how about we go and compute all of this, do all the computation of the raw data on the space station, because there were 2 servers available from HP, and we partnered with HP and we used their servers. It had a GPU, and the whole thing took almost, like, I think 6 to 8 hours. So at the end of the 8 hours, we have the results ready to be handed over to the PI. So from weeks to literally a day, we were able to do all this computation. So this is just one example, and we are also trying to see what can be done on the satellites, because of course space station is much bigger than a satellite, and the next generation of satellites, which will be more software defined, so we can push some workloads. We can have as simple as a model which detects if you're doing imaging, is this image full of clouds or is it actually looking at certain area? So you can avoid downlinking, because downlinking is expensive from space, right? In terms of bandwidth and throughput. So you only want to downlink which is meaningful. The rest you can just discard. So things like that. And okay, the next use case is space stations. We also work with them. If you have seen the live videos of space stations, the things, because of microgravity, things are floating inside, right? So one of the challenges was when they put certain things at certain places inside the space station, it's actually very congested. By the way, if you guys have that Oculus metaverse thing, right? There is an app for space station. You download and you can actually go inside the space station, and it is so real that you're actually floating inside, and you can see it. Actually, you can actually open the hatch and you can go outside and do a spacewalk. So it's pretty cool stuff. Anyways, going back to this, so idea was, okay, can we use any machine learning or deep learning AI techniques to figure it out from the video feed that I put my, let's say, screwdriver or something here, and now when I'm going back, it's not there anymore. It has floated. So the imaging can detect and can alert that this thing has moved from its location. So we worked on that. Yes, the space industry does include the sensors and parts as well. Yes, depending upon what, if it's a satellite or a space station. I'm just looking at stuff in the chat here. I'll just leave the window open here. Okay. Okay, another use case is a very hot topic in the industry, the sustainability, space debris, space traffic management, space situational awareness. So like you can see, I won't read the numbers. You can see all these numbers about the debris and everything. So to date, we have, like, I think 7,000 or some operational satellites in the low Earth orbit. Starlink only itself has more than 3,300 satellites. So half the satellites are just put in last 2 years. And you can see this in this picture, you can see the train of satellites. That's what the Starlink is. So now that, yes, it's really cool stuff too. And for all the remote areas, if you go outside your, the cities, your connection speed drops drastically. But with a full global connectivity, think about the marine traffic, right? All these hundreds of container ships which travels every day across the globe. Think about the airplane, right? If we have used the internet connectivity in last few years, the speed is like dial-up, like less than 1 meg or 2 meg. Now with these, there are already airlines who have tested this out in the US with Starlink, and the marine industry is also testing it. And then you have all these other ships for cruises and all this stuff. So now you will have a global connectivity, but it creates challenges like debris, like so much stuff is out there, and there is a chance of collision, right? So how do you predict? Just nothing in last year or two, space station had to do a quick maneuver, like I think 4 or 5 times, and it's a very expensive operation because besides, I mean, space station, you have these satellites, you have very limited fuel, so you cannot just use that fuel for whenever a small debris is coming and you have to protect yourself, right? So how do you do orbit protection? How do you do a conjunction search? Then there's another challenge for the researchers on the ground who are using these billion-dollar radio telescopes to do Earth observation, the universe observation at night, deep sky observation. It's generating a lot of noise in the data. Please go ahead.
Okay, so it seems that this problem with you having orbital prediction of component combines physics and machine learning. So physics and machine learning, in our context as computer scientists, there is a field that is well known that has beaten this to death, which is the game industry, right? The gaming industry has developed multiple physics engines and frameworks, and those are working perfectly. You could see like PlayStation 5, for example, or any recent console gaming with perfect hardware that is absolutely fit for this task. So it seems to me the problem, and this is my question actually, is the problem how we develop more accurate kind of models? Or the problem is how can we achieve the same kind of accuracy with lower energy consumption? Because it seems to me also energy is a concern in space, especially if you want to do the computation over there.
Yes. No, so I think computation can be done. Yeah, it can be done. Probably for training, we do it on the ground because, like you said, right, it takes a lot of power to do that. So we only use edge right now for inferencing until we get more. But the big challenge is the data, right? As you know, as a data scientist, right? So your output is only as good as your input. And right now, this data is controlled by the military agencies like Air Force of different nations. And it's very interesting. If you look at US Air Force, they use this TLE, 2-element data, right, to predict these orbits, everything. If you look data from their point of view, the orbit looks like this. If you look Russians' data, it looks quite different. If you look Chinese, it's like, for example, saying that you're an air traffic control manager, and on your radar, a flight is coming from New York to Austin, and now you're seeing 3 different paths. It's a disaster. You don't know which one to trust, right? So so that's what's happening right now. There is a lot of, but the companies like Leolab, take a look at that. Just Google Leolab visualization, and this picture I took it from there. They have a live or near real-time live representation of the orbit and debris. And so it's a private company. They are putting up their own huge radars to collect all this information. So I think once we get to, and there is a lot of, and this is a very complicated problem because of all the different nations involved and all that stuff, because space is open, right? It's not like there are rules or laws yet. So unless we have a single view of truth, right, it's very challenging. So you, me, and we all can build our model and stuff, but if we are not looking at the same data, it's still a disaster. I don't know who to trust.
So amazing response. So now the question, how does IBM deal with that problem that you just described? Do
So
you take
yeah,
input from multiple sources and then extrapolate and interpolate and try to converge at one point? Or do you train your models based on all the data separately and then measure the accuracy based on your own testing? So how do you go by
that? So yeah, I think all of the above. First of all, acquiring data, right? So you need to have those partnerships in place in those different geolocations. So the thing is, in like in any other industry, also in space, because space especially is a very tough industry, right? In terms of, because it's a very specialized field with, you need a lot of you need subject matter experts. It's not like anybody can open the book and start doing this stuff. So in this case, what we do partnerships. Like, for example, Leo Labs, a partner who is, let's say, who already is putting up their own ground radars and building all these models to build this kind of predictions. And because we work with different, the US Air Force, we partner with them, take their data, take Leo Labs, do some fusion, and use our partner. We don't have to reinvent the wheel here. But what I am more interested is how quantum computing will solve this problem. Because this is a traveling salesperson problem. If you have to do a cleanup there with so much stuff there, and quantum is still far away, it's not here, it's probably, but when it's here, do we have the algorithms and enough qubits to solve this kind of problem? So we don't have to solve today, right? Because there are already people working. We have to look ahead, and it's just going to get more congested in the next few years.
Absolutely, I completely agree with you, and I think quantum computing is one of the game changers in the next 5 to 10 years for sure. And yes. I know for a fact that there is a huge push in the field. I know that for a fact in developing new, especially in security. Yes. Developing new protocols and algorithms to tackle the encryption in general and communication in the internet.
Quantum safe encryption.
Absolutely. So I'm not sure how is that gonna end up to be, but it's an interesting thing to keep an eye on for sure.
Yeah, quantum key distribution, quantum safety, all this stuff. It just protect your encryption. These are the security is going to be the first, and I will talk about. I have a slide on quantum also, so we'll talk about that also. So I think you have already seen my slides. So, all right, let's talk about sustainability and from the Earth point of view, right? So, you probably have seen this chart, the famous chart from United Nations, SDG, Sustainability Development Goals. And I think this is a very comprehensive, it covers many aspects of our daily lives. So the question is, how does space help in all of these areas? And I think space does help, again, by using the satellites, it almost help in all of these areas. So for example, if there is flooding, any type of natural disaster, or if with all this pandemic, which happened last couple of years, how the population was moving from different areas, right? And when there was drought in South Africa, in one of the major cities over there, how the population moved, all of this, because you're observing from the top, you are watching all these things. So space, satellites, that's why I think data and AI. And now with all this stuff which we all are going through, this explosion of generative AI, right? With GPT stuff. Actually, there was already a trend yesterday for GPT-5. There was a huge. I was like, okay, GPT-4 just came out, so this is like a genie out of the bottle. How are you gonna stop, right? And you probably saw, there was an interesting petition just 2 days ago. Stop this. Put a break on this for next 6 months, right? I don't think it's gonna happen. So, but we have to see how we can positively use that, and to work towards with the data we have, with the gaps which are missing in the data. How can we use these generative AI to fill the gaps and do something positive, meaningful? So, okay, I think we have touched this, like observation, all the different use cases. It's I think this is it is the biggest use case. And where from insurance point of view, the companies want to see if the roofs are, they want to be repaired or something, or if the parking lots, if the retail want to understand how their parking lots are being filled with cars during different kinds of seasons, right? One of the interesting use cases which I read about was, how you probably guys are very well familiar in where we have these big oil tanks in the outside field, those big ones, right? Their roof is a floating roof. So basically, depending upon how much crude oil is there, the roof just tells you. So for example, let's say, brother, hold on. Yes. One of our brothers here, he owns these oil tanks, right? And he comes and tells us, I have 90% oil in all my tanks. I'm like, okay, let's verify that. So we asked the satellite to take an image, and with all these 25 centimeter, and I don't know if you have seen the images. I think I have one image here, right? I think this is like 35 or 50 centimeter, and 25 centimeter is with 10 centimeter. That's how you can read the sign now on the street. So anyway, so they say, oh, we have this. I say, okay, sure. So we look at that oil tank, and if let's say that the oil is only 30%, it's 60% empty. So when the roof is down and it has a wall, with the sun, it's going to create a shadow. It's going to create a shadow from the wall on the roof. From there, it will be a right triangle. You can calculate. You know what? It's not 90%. It's only 30% filled. And so that's how they are using this satellite imagery to figure out all these things. I mean, it's a no-brainer, right? If you live in your home, right, and there is no roof, and somebody watches you for, let's say, 30 days. After 30 days, I know exactly your pattern, what you do. And that's what these satellites are doing. And their data now is only, I think, 12 to 24 hours old. They have a fleet of satellites. They have constellations who are constantly scanning using these advanced techniques like SAR and stuff, and gathering enormous amount of data. And in future, when we have the optical connections, imagine how quickly it's going to dump down the information almost instantly. And it gets computed in next few minutes, and you have the latest imagery of whatever area you're interested in. Go ahead.
Thank you, brother, for the illustration. To me, it's very interesting to have imagery with this such high resolution, because me as a student working on research, I've done a little bit of projects on remote sensing. The only data I've been to get my hands on is like 10-meter resolution. It was like Sentinel-2 or Landsat satellites, which is good enough to start with. But seeing imagery or have data available at this resolution, I'm sure it will help open a lot of activities, a lot of projects, a lot of ideas. I'm interested in how such maybe students or university say faculty can work on or have access on such data.
No, that's a great question. So you're right. The public data is only available at that 10-meter or 30-meter range, right? From Sentinel, from European satellites, Copernicus program, or the Landsat satellites here in US from NASA, right? Now, I think from university's point of view, it has to be, again, a partnership collaboration with these major private companies like Maxar, Planet, right? Like ICEYE, partner with them, right? And I think what value the universities, researchers can bring is this whole phenomena of generative AI. So you say, you know what, give us your images and let us use the AI techniques to further enhance your images. So it's like you are giving something to them, they are giving something to you, because all this data is available, but it's very expensive to get, right? So it has to be some partnership where you say we work with these universities and our students get trained into this new industry, and we help them by building whatever the AI models we can to use the GANs and all these different kind of techniques to enhance these pictures. So I think with that collaboration, yes, it's possible. Otherwise, you can just go to their website. They will give you like, I think 10 samples free. So that's all you can get. But I think
I'm sorry to cut you off. I'm sorry. Here is also some thoughts on I know for a fact that archaeology also uses these imageries to do some analytics from the top in order to find areas that worth excavating. And I know that also for people who are connecting from Saudi Arabia and who are from Saudi Arabia, we all know that there is a huge movement in archaeology in the northwest of the Arabian Peninsula in Saudi that is absolutely virgin areas that never been excavated before or looked at before. So I think this is a great opportunity for universities in Saudi to actually collaborate with the organizations that do such analytics and collaborate with them in order to enhance or analyze these imageries and give feedback on a mass scale. It's like for them, it's going to be a crowdsourcing of data analytics, which will alleviate a lot of the tasks from their side and would also help the students and in university context to gain some knowledge and some hands-on experience with such data. But this is a thought for you, maybe Abdulaziz, to probably chase it further later on.
Well,
No,
I'll
definitely,
give it
yeah.
my best.
Yeah, talk to your professors and dean and say, no, make these connections. And actually, you mentioned in the north area, right? I just read an article, I think 2 days ago, that they found these remains of these goats of this place, right? Which probably dates back 7,000 years ago. And they're finding these different areas. So I just read this article.
In fact, it's one of the oldest ancient historical sites and cultures. They were found in that area. And there's something called Al-Mustatil. I'm not sure if you've heard of it. Al-Mustatil is one of the things that were found and coined as a concept over there. And it's just one of the oldest tombs. And it's just fascinating, absolutely fascinating. Yes. Put a note on it, Abdulaziz. When I come back to Saudi, we have to, maybe we can chase the project.
For sure. This is a subject we cannot cover it in 1 hour. I'm sure we can have a lot of discussions further on.
Okay, then quickly, just in interest of time. So then there is just a whole, we for past few years, the 5G. And what 5G means is, right, it's a much higher bandwidth and throughput, but in a short distance. It's not like you can sit here, right? So basically, it was built for edge computing in mind, for the industrial 4.0 or 5.0, where you have these big facilities, like let's say your university, right? And you have this 5G in the whole campus. And you have this very fast connectivity in that given certain location. Now, the next generation of satellites, the satellites can act as a backhaul. Like today, the backhaul is done to the ground, right? Or under the sea, all this cabling which happens for the internet. Now you have satellites which can take your traffic from a different place. A good use case is, let's say, precision agriculture. So you're watching the for your yield for a crop, increase the yield for the crop, or you're watching for the health of your plants. You have sensors placed all over the area. And then you use like a LoRaWAN protocol, and you grab the information, you have a gateway there, and that gateway connects with a satellite connectivity, and it can dump to information wherever your terminal is, in cloud or on-prem, wherever. So that's another use case for enabling this IoT. Edge computing can be done at many areas, like all the way from your data centers to wherever your far edge is on the terrestrial networks, where maybe where you have those big radio dish antennas, because data comes over there first, right? And then yes, and then so edge computing can happen along the way depending upon your use case. And the idea of edge computing is, right, that extract the value out of data as soon as the data is produced. Now, for example, think of autonomous cars. When they are driving on the road using different kinds of techniques, if they have to go to a data center and ask, should I put a brake or not, the car is gone by that time, right? It has to make that decision in milliseconds or microseconds. And that's what edge computing is. There are models built inside the car. They're evaluating the information and making instant decisions. So that's what edge computing is. Okay, blockchain. I just want to put out there that the blockchain, the concept was this whole trust, transparency, provenance, basically taking the manual element out of the whole supply chain. So if you think about these very, very multi-million-dollar assets, satellites and different components, the supply chain is very complicated. How do you know this one part which came into this subsystem, that subsystem goes into a main system that becomes a part of a satellite? Do we have a provenance? Do we have a history, auditing trail, where it came from? How did it got all tested, everything? And that's where the idea of blockchain was, right? To provide all this transparency. But the challenge with blockchain is all 9 planets have to be aligned for this to happen, which means your system has to be end-to-end digitized. So you can get information, right? If somebody has to write something for you, you already broke the rule, right? That's why it has been challenged to actually implement. There are a few places have been implemented in the world, like the Maersk for the those big container ships. They did that, but still, it will happen maybe later, but not right now. But it's just an example to show. Okay, quantum computing. So what quantum in general, right? It's for the optimization. And what can we do? See, one is the collision avoidance, which you talked about, with all this debris. How can we avoid that, or how can we do the cleanup? Other is the spacecraft trajectory optimizations. So all of these different kinds of, and pharmaceutical is a huge industry. Actually, it's the first industry for quantum computing, and then financials, and then all these areas, right? But we are still far away. But anyways, these are the areas to think about. And any of you, you all are young kids over here, right? Go and start learning about quantum computing, because this is coming. This is the future. And
Not
IBM.
me. I'm not that young. I'm probably older than you, Mr. Altaf.
So the quantum, the KISS kit on IBM, right? They have a very good program. It's free. You can access the quantum computer, right? You can access the simulators, but get familiar with that. And if you have your younger siblings who are coming into computer science, ask them to start learning quantum now. By the time they graduate and go to work, they will be ahead of many people in the world. So, okay, now let's talk about the last but not least, about the Cubesat. So the story is, when we started our group, one of the goal was, okay, I want to launch a Cubesat, because it's to understand the whole thing. So I thought I have a 3D printer, I'll print it, put a Raspberry Pi there, do some programming, and we'll call NASA, because we work with NASA a lot. So can you please put our Cubesat there? No, it doesn't work like that. There is a guide by NASA. If you just Google it, NASA 101 Cubesat, it's like a above 100 pages guide. It goes into step-by-step details of all the logistics and everything you need to be in place to actually do a launch, and all the things needed. So it's very good. So soon we realized it's going to take a lot more logistics to do this. So we said, okay, let's do what we are best, and let's find a partner who actually build a CubeSat. So we found a partner called Indirosat in Bulgaria. They actually build this CubeSats, and we work on the software aspect of it. We said we bring our platform like OpenShift, Microshift, and Podman to run a container. So we'll do the software aspect while you take care of the hardware aspect. So we work with them. We launched this on, I think, May 25th. Yeah, May 25th last year. And it's been running since almost 10 months now. And we are getting these very nice images from the, it's right now, it's at, I think, 522 kilometers. So there is the NORAD ID is 52770. So you can just search for it. So anyways, so that was our, and the purpose of this thing was to democratize access to space. What that means is, while going through this process, when we experience that it is so hard and challenging, even in these developing nations, to put something in place. Imagine all the other underdeveloped nations. It's almost impossible for them to put something in space. So we said we'll put this up there, and we'll give it access to everyone, all the schools, so they can push their code up. So if you have a Python code, which you want to try, we can push up. We already have 5 schools working with us. And but the challenge is the bandwidth, right? So the uplink is UHF. The downlink is X-band. X-band, we can get close to 300 to 400 meg in one pass. A pass is like 6 to 7 minutes. That's not a problem. The uplink is challenging. It's almost dial-up speed. So the file has to be literally in kilobytes, like maybe 5-10 kilobyte file. So if you have a Python code, you want to try it out, we'll push your code up to the Cubesat. These are a few of the pictures we just got. I mean, we have like, I think, 30 or 40 different images, but this is like, I think this is Bulgaria. This is New York City. That's Hawaii. This is Bahamas, that's Pakistan. This is somewhere in Northern Africa. So I'm working on Saudi and all this area. I have already scheduled all these images. So inshallah, hopefully in next week, 2 weeks, we should be able to capture those. Yep. So if you have any area of interest, let me know. I have all the major areas of the world. I have scheduled them so we can take the images. But if you want a particular area, we're happy to do imaging for you guys. Okay, Microshift, this is what I mentioned, the platform. This is a platform, a Cube platform where you can run containers on, which is built for devices like Raspberry Pi or smaller device. And we have this running on on our Cubesat. So you work with our Red Hat team to build this. And here's a white paper. We work with different industry leaders to put a perspective out for, what it means to be working in space and doing. So the main theme was collaboration, like I mentioned before, because it's a very specialized field. So we can't expect everybody to be, reinventing the wheel here. So let's do what they do best, our partners in certain areas, and we bring what we do best from our point of view. Like, for example, if you saw the work we are doing with Sierra Space, there's a press release which came out in November. They are going to build the next generation of space station, which will go up, I think, end of this in next few years. So we are going to build them a hybrid platform on which they can run their applications on. So I would love to build a space station, but I don't have the skills to build a space station, but I know the software. So I bring that, they build that, so we can work together. Last but not least, this generative AI, this is everywhere. I think this is also for our younger generation, and and I'm also learning. We are always learning, right? Go and learn this stuff. This is what is, you probably are not old enough. Like 20 years ago, I remember when I was just out of school or working in my office, one of my managers came and said, "Naeem, I want to show you this new search engine." And it was called Google. So he typed something and it showed you in 0.005 seconds, it brought these many results. And we were like, oh my, what is this, right? Because you used to have Yahoo and Alta Vista and all this 20 different kinds of search engines. And then nobody looked behind. Google was it. And now, since the GPT, forget about everything else. I mean, I'm playing with GPT all the time, trying to see what it's very cool. And then from text to images, the mid journey I've been playing with, but now with GPT-4, you can do everything because it's a multi-model thing. So it can do images also. I haven't tried that yet because it's Ramadan, so I want to spend time wisely. But inshallah, after Eid, I'm going to get the subscription of GPT-4 and then play with it. So yeah, so again, think of whichever industry you are in. Look, this is a game changer, this whole GPT is. So think about, how can I apply to my industry? Whatever industry you are in or you want to go in, what can I do? Data is everywhere, right? And now everybody is so impatient. They want the results yesterday. I just want to know right now. This GPT-5, which they're talking about, if they have to, which they, of course, they will, when they train this thing, you need 25,000 GPUs to train that thing. Do the math of their thing. Not every, so I think going forward, what I see, it's going to be these few companies will build these enormous, these foundation models, enormous amount of data, and then it will be a subscription to each vertical industry, so they can take that and build on top, take their knowledge and build on top. Because I cannot go and build a foundation model with, first of all, I have no access to that data. Even if I had to compute that, it's going to be a lot of money to do that kind of thing. So seems like going forward, this model will be. But yeah, I think this will be changed. We should be doing amazing things, right? I mean, we have so much, imagine, we have so much classic text for last 1400 years, right? I'm always thinking in that, what can we do with that? Okay, it's in Arabic language. What can we do with that? Can we extract? There's so much information there. Can we extract something and do something with it for a general public, right? So I'm just saying here, we all, whatever areas of interest are, think about it, and let's innovate. Let's do some amazing things with it. Okay, and think that's about it.
Thank you.